Hello everyone, I welcome you all on Data Phoenix webinar. Today we will speak about synthetic data together with Supreet Kaur. She is AI product manager on Morgan Stanley. Supreet, your stage.
Oh, awesome. Okay, I think my screen is visible. I will put it on presentation mode, but I will also take a moment just to introduce myself and talk a little bit about my journey. Yes, I am right now in Morgan Stanley. I am the Assistant Vice President in the Products and Strategy team. Building data driven products that are powered by AI. And but prior to this, I have been in multiple roles. I actually started my career as a data scientist, building demand forecasting models for the healthcare industry. Then I pivoted a little bit more into data strategy and technology strategy role, where I was still building data powered products in the consulting arena, though, and that was in the healthcare space as well. And then I decided to change my industry altogether and move to finance. So most of my experience has been in the regulated industries, and hence synthetic data as a topic has been very close to my heart. As you all know, that privacy is really important, especially for regulated industries or any data-driven organization for that matter. So I hope you enjoy this whenever you are watching, if you're tuning in right now, or if you are watching it later. And I will start with the agenda. So the agenda is pretty straightforward for today. I will start by giving an overview of what is synthetic data, just so that we all are on the same page. I know that there are multiple definitions on the internet if you research what a synthetic data is and how complex of a topic it can be. We'll talk about some of its advantages, the use cases around it, and I'll also dive deep into some practical techniques to generate synthetic data, some challenges associated with it, and I would conclude the presentation by talking about the best practices if you want to deploy and implement synthetic data in your organization or your day to day. So let's start. So, what is synthetic data, right? So, as the name suggests, synthetic data is artificially generated data that possesses the same statistical properties as the real data. However, it requires specialized techniques and skills to generate it effectively. And that's why, if you are in an organization where there are data scientists, machine learning engineers, you will find them working on synthetic data because they have those skills to create and generate synthetic data. And today we are obviously taking a moment to explore why synthetic data has become such an important topic for discussion. So, another interesting study that I found that I wanted to share before I dive deep into what synthetic data is, that Gartner has actually predicted that by 2024, 60% of the data which will be used for developing AI analytics will be synthetic data. So this should alarm us, and the statistics should motivate us to learn more about the synthetic data, right? So in our data driven era, companies are obviously relying on data. Every day you see we everyone's talking about data driven products, and especially with the advent of generative AI, people are taking data seriously. But it's possible that you might be in a situation where you might not have the data, or your data is extremely private and you cannot use it to build models. So synthetic data is for you, and this video is also for you. So it can, as I mentioned, it can serve as a powerful tool when you are trying to save or mask the private information of your customers. Synthetic data can come to your rescue. And another point is that if you are trying to do some kind of breakthrough research in the world of artificial intelligence, synthetic data can again help you generate the edge cases and some edge scenarios just by the way it operates. And you will understand more as to why synthetic data has such special properties. But all in all, it is just a artificially generated data which can be generated using some specialized techniques. Okay, so let's talk about the advantages. I'm sure you would have gained some with the definition, but one of the crucial aspects is obviously retaining privacy of customers. There is a study that brands will trust you, brands will engage with you if they know that you are very diligent with their data. So it's very important that if you are trying to create a brand, that you develop that trust within your customers, and hence it is our due diligence to develop the privacy and to protect the privacy of your customers, right? And when synthetic data is generated, and as I talk about the techniques, you'll know this more, that all the PII, which is your names, your vitals, it could be your SSNs, those are completely artificial. So even though you do have those PII attributes, the information in those attributes is artificial. And hence, it allows you to be able to use that data for further modeling or your analytical processes, right? And then the second part is that it is they have the potential to create edge cases and scenarios that have not existed historically. So, this has been proved to be very effective, especially in the self automation industry or self driving cars, if you have heard about them. So, when some of the users or some of the researchers, when they're trying to work on the self driving cars, you have to know all the scenarios that a driver can encounter because you're now working on a self-driving car. So how do you know all of those scenarios? Everything cannot be in the historical data. Everyone's driving style is unique, and it can be almost as unique as your DNA. So in those cases you do need some simulated scenarios, and that is where synthetic data can help you to generate those simulated scenarios. And another advantage of synthetic data is that if you are a startup, and if you're not a legacy organization, or you're just a small scale business or a small business who's just starting out, and you do need some kind of your customer information, you have some historical records, but now you want to augment that information or increase that data set just to be able to perform further operations. Synthetic data can prove to be very cost effective as well as a very useful approach for you. Not only will the synthetic data increase the size of your data set, but just by giving you those unique scenarios, it will also capture and give you that diversified data set that you actually need. And sometimes diversity is actually missing from our real data, but it can be present in the synthetic data if generated properly. And those are some of the advantages of synthetic data. Now let's dive deep into some of the use cases, right? So if we talk about finance, like obviously in the realm of fraud detection, synthetic data does play a critical role, in developing and testing fraud detection algorithms. So by generating synthetic data, they accurately mimic those fraudulent patterns, and that helps financial organizations to enhance the fraud detection systems. And you are already two step ahead, and you know those scenarios that might have not existed in the past, so you can make your system smarter, and you can just be one step ahead of all those fraudsters and the fraudulent activity. So that is one of the most powerful use cases in the financial industry. Another one being traders, who also benefit from synthetic data, because when they're evaluating marketing conditions, and then they're making realistic trading decisions, so they leverage synthetic data that simulates those real world market scenarios. Then they are able to analyze and strategize with greater confidence as to what the next step should be, or where is the market heading to. So synthetic data can provide people that way of doing that. And further, another one being that in models that leverage customer transactions, as I said, synthetic data can give you a way to mask all the private information. And a lot of times, financial institutions do work on some of the use cases that has customer information. So when you're trying to save data privacy, synthetic data is really powerful. It still retains your statistical properties of the real data, but at the same time, now you don't have to worry about protecting your customers' privacy. Okay, now let's talk about healthcare. So, one powerful use case in healthcare is cancer detection. So, if you have worked in healthcare, and I have, and I can tell you this, that when the companies are working on developing drugs, it is a million and sometimes $1 billion investment, right? And they're still not able to know what the vitals would look like, or what would the mass shape look like that could possibly be cancer. So you need, in this case also, you need a lot of unique simulations and unique scenarios just to know what that shape would look like, just so that you can enrich your data, make your historical model stronger, so that when a real patient comes in and you scan them, you are able to know whether this is cancer or not. And again, those mass shapes, the vitals of a patient can be very unique. So synthetic data can help simulate some of those unknown scenarios. Another one for healthcare is as well, that you have to mask the information, you have to mask the customer information that is required to train and test models, and synthetic data can help you there as well. And I think the last one and the most useful, which is a use case, is that the simulation can also help from a policymaker's perspective. So we all know that when the pandemic hit, everything that we had thought in the past almost stopped working, and everyone had to think about those new scenarios and had to tweak their models, tweak their policies, tweak their data just to accommodate this one off event, right? But policymakers can generate synthetic data that represents different scenarios, and then that is where you can actually know the potential impact of all of these policies and of all of these pandemics, just so that you are prepared. Not saying that a lot of these pandemics happen, but if you have learned anything and you can enrich your data with a lot of these one-off scenarios, your models will become smarter, and you will be prepared when such an extreme situation occurs. And it's also at that time of stress, when you're trying to devise those important strategies, it can be daunting. You are under a time pressure, you don't know what you're doing would work or not, right? So just being ahead of the curve and being ahead of some of those future situations, synthetic data can help people, policymakers, or just researchers in general. Okay, so now let's talk about some of the methods. I'll cover some 2 to 3 methods here. The first one being GANs, and you will hear it all the time when you're searching for literature. GANs is such a popular method. They are basically a powerful class of generative models that have revolutionized the way we generate synthetic data. And I think all of us are clear at this point what the synthetic data is, and I'll also talk about the framework of GANs, right? So at the heart of GANs, there are 2 neural networks. One is the generator network, and the other is the discriminator network. So the generator network takes random noise as input and sets out a mission to generate synthetic data sample, right? And those synthetic data obviously have a resemblance to the real data on which the GAN was trained on. And it uses the power of deep learning to transform noise into meaningful data. And on the other hand, we have a discriminator network, which acts as a binary classifier. So the primary task of a discriminator network is to distinguish between the training set and the synthetic samples generated by the generator network. So it basically hones its classification abilities. The discriminator networks becomes more adept at knowing what is authentic and what is not authentic. And specifically, it then tries to tell the generator, okay, this was authentic, this was not, or not authentic. So basically, this was real, this was fake, and this continues. And this is like an iterative process which goes on until the generator cannot fool the discriminator anymore. So this obviously there's a lot of literature out there, and I'm just touching on it. So I do urge all of you, to read about this, because this is a very complex topic right now. And we are at a stage of research where there are different types of GANs out there. There are conditional GANs, and then there are GANs especially for finance data sets. There are also GANs available for healthcare data sets, and research has really evolved on this topic. So I just wanted to give you that this exists. So this is like a very basic summary of GANs, but no way is this an exhaustive explanation of what a GAN is. Um, okay, so the other method is obviously data augmentation. And data augmentation is again a powerful technique, as I mentioned in some of the use cases, that if you want to increase the size of your data set, you do use data augmentation. And in the context of tabular data, there are several approaches to augmenting the data, such as you can scale numerical features, you can add random noise, you can fill in missing values, so on and so forth. And by applying data augmentation, we introduce new variations to the data set that the model has not encountered during training. And this helps address the issue of overfitting. It improves the model's ability to generalize on the unseen data. And by exposing the model to diverse and augmented sample, you are basically enhancing the capacity of your AI model to handle different scenarios and hence give you accurate predictions. And there are some examples of data augmentation that I've mentioned here, like we have feature scaling, you have feature noise. So feature scaling is basically you scale the numerical features to a specific range. Then there is missing value imputation, and I'm sure you all must have encountered missing values at some point in your career. So you can actually fill in the missing values with the estimated values. You can even decide how you want to use it. So data augmentation can be used in a different way and also in a variety of I would say kinds of data set. If you have a tabular data set, these are some of the examples. But if you have an image data set, it could mean like rotating your image or scaling your image, and changing the features of this image just to increase the breadth of your data set. Okay, so now the number one question that you should be asking at this point is, I'm good, I've done synthetic data, but how do I really validate it, right? And there are multiple techniques out there. I've just tried to summarize some of the techniques that I have found useful. So the first is we can talk about is adversarial validation. So it's basically if you want to determine the quality of your synthetic data, I think this is one of the best techniques that you can use so far, which is that you take your machine learning model and train it using your synthetic data and real data, and then compare the performance. But I understand that this is only possible if you have some level of real data, like at least 1,000 or 2,000 records. Like if you have 5 records, obviously this technique won't work. But if you do have some kind of real data, I would highly recommend training your model first on the real data, then on your synthetic data, and then compare their mean square error or any kind of metrics that you're using to test the accuracy of your model. Compare those metrics for the two data sets and see what comes out. That will really tell you about the synthetic data. And basically, and this point actually surprised me, is that if the model performs exceptionally well, it actually shows that your artificial data and your natural data are entirely different. So when you are trying to see those metrics, be careful and be cognizant of this fact. Another one is feature importance. So as you are training your model on both data sets, you can also do the same for feature importance. And then you can compare the order of feature importance. So once you see the order, I would highly recommend that at that point you can actually talk to your SMEs, or you can talk to your business stakeholders, just to see that if that order of feature importance makes sense from a business standpoint. I know that you have it from a numeric standpoint, but then if you get their vision and get their opinion on board as well, you'll feel more confident with your results. The next being, like, you can compare your synthetic data with other techniques, right? So which essentially means is that I walked you through GANs, but then there are other techniques as well in the market. So when you're generating your synthetic data, you can actually use multiple techniques while generating the synthetic data, and then compare just the statistical properties of the data, or even train the model on those, or the feature importance. So that will honestly depend on the depth of your use case. And I know that this could be computationally expensive validation technique, but if you have the time and resources, then why not? And then the last one that I partially mentioned, which is to seek domain expertise whenever you can, just because the experience that business stakeholders can bring on the table, even though they might not be technical savvy, is we cannot compete against that, right? So it's always good to have that expertise, and just know what they think about the data that you have generated. So yeah, so we are almost heading to the conclusion, but I would obviously like to discuss the challenges. Every coin has two sides, and so does synthetic data. It's not perfect. Like the first one being that there are still some concerns around the bias of synthetic data, and though there is ongoing research, but nothing is concrete yet to finalize, does synthetic data have bias? That is still an open question. Another one being synthetic data sometimes may struggle to predict or replicate the rare events or outliers present in the original data. So I know I was taking the example of one-off pandemics, or some very unique driving scenarios. So if those driving scenarios do occur a lot in the real data, even though they occur less times than other scenario, synthetic data might still be able to gauge that it is still an event which is possible, and it might be able to mimic it. But it's possible that if your real data, let's say, has 2000 rows and only one outlier and one situation is very unique, it is possible that synthetic data might not be able to replicate it. But this is very much dependent on your, I would say, the base data that you're training synthetic data on, what is the use case that you're working on. So this is a possibility. So it's just important to know that this might happen. Then the next one being that if there are a lot more complex dependencies between your different variables in the data set or interactions, synthetic data may become more challenging to train. So at that time, it's also important to look at some of the hyperparameters, let's say for GANs, and play around just so that you're able to replicate it accurately. And then the last one, obviously, being synthetic data does require specialized skills to generate. And as I actually started my presentation with this, that you will see a lot of data scientists, machine learning engineers, and people who have specialized skills working on synthetic data, just because it does require that kind of technical expertise. So it depends on where you are in your organization structure. Is it easy for you to buy data, or is it easy for you to generate synthetic data? So that's a powerful question that you have to ask within before you decide if you want to try this route or not. And my last slide, which is I would just talk about some of the best practices. The first one that goes without saying is that if your data quality is poor, your synthetic data generation techniques will fail, and they will be poor. So if you are planning to work on synthetic data, it's important to monitor your data quality and ensure that your quality is up to a standard that the synthetic data effort wouldn't fail. And if you are unsure of it, I would highly recommend that you develop a data quality framework and measure the data quality over a few months before you decide to make this big investment, because at the end of the day, it is expensive to generate synthetic data. And all of those data quality checks, some of the things I've mentioned, you can check inconsistencies, bias, inaccuracies, etc. And then the next one is obviously, once you have generated the data, you need to validate the quality of synthetic data. And if you are doing it on an ongoing basis, then you also need to have some frameworks in place to be able to detect that quality and ensure that you're getting the quality that you expect. And then obviously synthetic data generation is an iterative process, right? So you need to continuously refine your models, you need to refine your techniques, just to make sure that you are getting what you would like to, and you are achieving what you would like to from synthetic data. And that can be done by seeking feedback or having a feedback loop, where it reports, okay, what does the synthetic data look like, or what do some of the statistics that really matter to your organization look like, and continuously monitoring it on an ongoing basis will give you a clear picture as to what's happening. Validating bias is another one, which again goes without saying that since there is a threat that your data can be biased, you should use some kind of fairness frameworks, just to make sure that your data is unbiased. And the last one that I also mentioned in my last slide is, have specialized talent. If you cannot afford that, think about just buying data or procuring external data. So do all of those calculations before you embark this difficult yet meaningful energy journey. Sorry. So yeah, that is it. So I'm gonna end the presentation now. I'll stop sharing my screen.
Yeah, thank you for this overview and introduction to synthetic data. We have several questions. Let's try to answer to them. First, about what is the best way to generate synthetic data while using the GPT-4 API?
Oh, I haven't tried it using GPT-4 API, so I don't think I can answer that question. But if you do, then let me know what that looks like. But no, I would still go with the legacy techniques that have worked before, just to see.
Yeah,
So that.
and what is your experience in generate synthetic data? How you do it before?
Yeah, so obviously I cannot talk about what's exactly happening in the organization, just because all of that is confidential. But in general, I can tell you, when I talk to a lot of finance professionals, that they have been, obviously as I said, it's an iterative process, but they have been able to replicate and deal with the fraud use cases specifically, and a lot of organizations are inclining towards the anti-money laundering and fraud use cases. So yes, I would say that yeah, organizations have been successful, and some of the data is also private, publicly available if you Google it, as to what those models look like. So yeah, feel free to do that research.
On my experience, when on one project I need to generate synthetic data, and we don't have a large data set, we use some games and some uh, framework for
Correct. Yeah.
generate. But it was image. We need to create some images with
Yes.
some objects. So yeah, it's very helpful. For example, use Unity for create
And it's
real.
actually a very good point that you bring. There is so much information on the internet that's available about synthetic data in images, but still very less information on tabular synthetic data. So that is still an evolving field, and you'll find very less open source codes on tabular GANs, and it's still I feel it's still an ongoing, research.
Um, okay. So next question about have you been able to create synthetic data sets that
Yeah, I think I
replace?
have to pass this. I think I've already like spoken about a lot of use cases that I knew about, or that I've worked in the past in the healthcare sector as well. So yeah, I just wouldn't repeat that.
Okay.
How do you get access to seed data? What do you really mean by seed data? Is that like the base data or the real data? What does seed data mean? I'm not sure what seed data is, honestly. Have you compared open source and commercial tools for AI generative synthetic data? No, I haven't tried any commercial tools just because for the industries that I work for, they believe in building things in house. So it's mostly been using open source, but at the same time, tweaking it for our own organization. How much of the quality improvement work is project specific? Like with a new project, you start quality improvements from scratch. So I am thinking this is talking about the data quality. I mean, I'll make that assumption that this is talking about data quality framework. So that's actually a good question because I feel that data quality is a two-level process, right? One is very specific to your project because if you want XYZ three data sets, definitely you'll be monitoring the quality of only those three data sets and you won't care about the others. But just on a bigger organization level or just on a bigger team level, you still need to have those data quality frameworks in place just so that you are not grappling for data quality frameworks when you actually need them. You should already have them handy and then think about a lot of those use cases that you want to build around them. And so I think it's useful to not think about it in a project specific way but rather in a team org or a sector way. So yeah.
Yeah. So thank you for your presentation, for answer for for this question which our audience asked, and this yeah.
Of course. Yeah.
Um, yeah, thank you for all who was with us. Don't forget to subscribe to our YouTube channel. Our video will be published shortly of this webinar and previous also. And don't forget to comment, write your idea. Yeah, thank you.
Thank you.
Thank you. Bye.
Bye.